Okay, let's take a look at the humerus. All right, we're going to try to identify some bony landmarks. So let's take a look at the first one. What are we looking at here? What's the name of this landmark? Now, what is the name of this landmark? And this one, right here on the outside. So you got this one, and then there's a landmark that runs in between. What is the name of that landmark? Now let's roll it over a little bit, and we're going to take a look at the middle of the humerus. And what is this landmark here? All right, now let's go down a little bit more. And what are these two landmarks? It looks like there's one on both sides of the distal humerus. What about this? I wonder what this is called. And there seems to be another landmark right next to it. What is that called? Ooh, this is an interesting space. I wonder what the name of this space is called. Oh wow, there's another interesting space on the back side. I wonder what the name of that is. Now, let's take a look at the forearm. Let's begin with the proximal forearm, or proximal radial ulnar joint. Obviously, it's made up of the ulna and the radius. So let's begin. What is this landmark called? I wonder what it articulates with. What is that little point called? I wonder where that goes. What is this landmark called? I grabbed a pencil so I could point out some of the landmarks a little bit better because this one's kind of tough to show you. What is this surface called? What's the name of that landmark? What shape is it? Now, let's take a look at the radius. What's the name of this landmark? It's round in shape. What's the name of this landmark? I wonder what muscle attaches to it. Now we can take a look at the distal radius and what's the name of this landmark? Now let's take a closer look at that articulating surface of the distal radial ulnar joint. Right here where my pencil is. What's the name of that landmark? And what's the shape? Would you say it's concave or convex? Okay, let's take a look at the arthrokinematics for elbow flexion and extension. The first thing we need to do is determine which side is concave and which side is convex. So obviously this is going to be a concave surface. So the semilunar notch is considered concave. Now we're going to look at the distal portion of the humerus, and to be specific, we're going to look at a side view of the trochlea. So the trochlea is considered convex. So when it comes to open chain arthrokinematics for the elbow, the arthrokinematic rule in place is a concave surface moving on a relatively fixed convex surface. So what I want you to do, I put a little red dot there near the olecranon process. And I want you to pay attention to the direction that the red dot moves in during flexion and extension. So there's a better view of that red dot. Okay, so let's put these bones back together. To the left of my screen, we're going to call that anterior. And to the right of the screen, we're going to call that posterior. So during elbow flexion, which direction does the dot move? Anterior or posterior? And then during elbow extension, what direction does the dot move? Anterior or posterior? So let's look at it again. Elbow starts in a neutral position, moves into flexion. What direction is that dot moving in? From flexed to extended position, what direction does the dot move in? So flexed elbow, dot moves in an anterior direction. During elbow extension, the elbow moves in a posterior direction. So open chain, elbow flexion, arthrokinematics are anterior glide and slide. And open chain, elbow extension, arthrokinematics are posterior glide and slide. So just to recap everything, when we talk about elbow flexion, you're going to have a concave surface moving on a convex surface. And the arthrokinematics involved are same direction. So there's an anterior glide and slide as well as an anterior roll during flexion. And then there's a posterior glide and slide as well as a posterior roll during elbow extension. Now let's take a look at pronation and supination of the forearm. We're going to look at a superior view of the proximal radial ulnar joint. And we're going to use the red dot as our landmark. So, as you can see, this is the distal radius that's coming into view right here. We're going to take a look at the distal radial ulnar joint here in a moment. But for now, let's pay attention to where the dot is. We're going to call this neutral. So I'm going to begin to turn the radius. And as I turn the radius, I want you to think about what direction the red dot is moving in. So we just moved the radius into a pronated position, as you can see at the distal end right here. Now the dot is going to come back to neutral, but again, in this pronated position, from neutral to there, what direction does it initially move in? Does it move anterior or posterior? So posterior is going to be the bottom of the screen, anterior is going to be the top of the screen. So bottom of the screen, posterior, top of the screen, anterior. So we're going to do the movement again. We're going to go into pronation. And initially, that dot moves in the posterior direction. You can see it right there. So it's moving toward the bottom of the screen. Now let's take a look at supination. So supination, that red dot is going to move in the anterior direction. So the spin for supination is anterior. The spin for pronation is posterior. Posterior spin for pronation, anterior spin for supination. The way you can remember this is posterior for pronation. So we got the two P's, the pose. Posterior pronation. Posterior pronation. Sounds like a song. Just to recap the arthrokinematics with the proximal radial ulnar joint, You have a convex surface moving on a relatively fixed concave surface. Therefore, the rule that's applied will be opposite direction. So during supination, like you see here, you're going to have an anterior spin with a posterior roll. And then with pronation, you'll have a posterior spin with an anterior roll. Opposite direction arthrokinematics. So now we're going to look at the distal radial ulnar joint, and the distal radial ulnar joint, actually I need to change the position of this. Just give me one moment. Yeah, I'm just going to feel how smooth the bone is first before I turn it in the right direction. All right, there we go. Okay, so the distal radius, where it articulates with the distal ulna, the distal radius is considered concave. Therefore, the rule that's going to be applied is a same direction rule for arthrokinematics. So during pronation, you should see an anterior glide and slide as well as a roll. And during supination, you'll see a posterior glide, slide, and roll. The rule that's applied is same direction. So pronation, anterior, supination, posterior. So I hope that was helpful. I know sometimes the arthrokinematics for the forearm and the elbow can be a little confusing. If you need any help with anything, please reach out to me. You know where to find me, or you can just re-watch this recording. Okay, all right. Talk to you later.